So there I am explaining first question of probability and stochastic processes class of Professor Chen, homework 6. So the first question, in the first question we are given function fxy xy is equal to 1 plus xy by a as valid joint density function. The first part we need to find a. So considering the integration limits of a according to this, we solve this integral, and it will be equal to 1 as it's a valid joint density function, so a equal to 4. Now second and third question asks us that whether x and y are independent and uncorrelated. So finding this, so now mean of x into y is equal to, this is our joint density function, from here into xy, limits of x and y. Now integrating this, solving it further, we get ex y is equal to zero. Ex is equal to 0 and xy is equal to 0. So the mean of xy is equal to mean of x into mean of y. Hence this is correlated, but joint density function is not multiplication of function x and function y, therefore they are not independent. Now finding the joint density function of x square and y square. So let x square equal to z and w equal to y. Finding the Jacobian, that is dz by dx, dz by dy, dw by dx, dw by dy. Solving this, we get 4xy. Now this has 4 roots. Z is equal to plus minus, x is equal to plus minus z, and y is equal to plus minus w. Now as z and w can only be positive, and as we know that value of x and y is less than 1, so z and w will be between 0 to 1. Again solving the Jacobian with this formula, and finding our density function, placing the values of z and w. For 4 values there will be 4 terms. Adding them together, we get our final value. Now the other case will be that z less than 0 or z greater than 1, and w less than 0, w greater than 1. In this case the density function of zw will be 0. So the overall density function with respect to zw is 1 upon 2 root pi into 1 upon 2 root z into 1 upon 2 under root w for between 0 to 1 z and w, otherwise it's 0. And this is also equal to fzz, fww, as these two distinct functions are visible. So their x square and y square are independent, that is fzw is equal to fz into fw. Now coming to question 2.